好，點解今堂咁開心呢？就係因為我哋今堂係有 quiz 嘅，冇錯，有 quiz。冇温書就啱啦 ，open book，open book，因為唔係全部都係俾你試下個感覺啫。我哋會有60分鐘俾大家試。你用手機都得，我哋唔介意你，總之你有辦法 figure out 到就得啦，或者你用 Excel 做都得。Okay, 校長好。So I have to check. Just a minute. Okay. Let me send the score to you first. 16喎，係犀利嘅喎。Okay. Okay. So let's have a very quick look first. No, I'm going to do a summary. So you know your score, right? So I will sort some questions first, like this one. For safety reasons, which of the radio frequency range should be used with radio? Hey, how come one? Actually, the answer is in here, NXB1. Okay, about safety hazards. Okay, so where is it? Where is its answer? The answer is located here. Okay, the radio hazardous. Okay, 61. Evil strength. Okay, evil strength. Okay, so this is the only answer. So this is some hard fact. So you can just memorize it and you can go to exam. Okay. Nothing special. Nothing about the logic. Okay. Yeah, you have to do it. No, there are no 3 months. Okay, actually this is a very tricky question. So in all the ordinance and I would say ASL. Okay, in all the ASL there is only 3 time frame. Okay, just a minute. Where's it? 1 month, 4 weeks. 1 month, 4 weeks, and 3 days. Okay, you have only three answers in your mind. If they ask about time, okay, 3 days. What is 3 days? 3 days is when you change your address, have the addition or deletion of equipment. This is 3 days. You have 3 days to notify OFCA. And what about 4 weeks? 4 weeks is you return the discs to them. Or am I wrong? Let me check. If I'm wrong, and I can give you back marks. So you hope that I'm wrong. Four weeks. Am I wrong? Am I wrong? No. Let me check. 4 weeks. Okay. So where is it? Return of license and identification list. It is 4 weeks. 4 weeks. So what about 1 month? 1 month is OFCA have the right to publish your name, your address and your address. Okay, so this is 1 month. 1 month, yeah. So actually, if they ask you about time, you have only 3 options in your mind: 3 days, 1 month, and 4 weeks. Okay, no 3 months, no 21 days. Okay.
Logic of it.
Mm-hmm.
What's the difference between 1 month and 4 weeks?
No, but they write it very explicit in the document. So there is some hard fact. You can ask them why, but no, you don't. You never know. Yeah. So you see that within 1 month for publishing, not to publish your name and address. Okay. So where does this information goes? It is in Annex B4. In Annex B4. Because then nothing much to ask about the rules and regulations, so they must ask you something like this. Yeah. Let me check. I have already asked it I've also told you already in your exam. So basically, no Singapore, no South Korea, no Japan, no Macau. Hong Kong doesn't admit their radio license. Okay, so where does this information comes? In Annex B1. Or B4? Let me check. Or maybe ABA, yeah. So you have not much information here. No way. Okay. Emission license by the following countries with operation privilege equivalent to ASL of Hong Kong. So Norway is one of them. Okay. So you see there are not much Asian country here. So remember the history behind for European countries and the countries that was ruled by UK, most of them appears here in the list. Okay. No Singapore, no Macau, no Japan. Yeah, but have Malaysia. No, but they have Malaysia. And you see some of the African countries, which was ruled by UK previously. Okay, so this is how you can memorize the hard facts.
NSA.
Hmm?
How about NSA?
This Annex A, in Annex A. 5. Recognition of foreign amateur station license. Yeah, here. 5.1. So you see that, yeah. This is a tricky question. What's named telemetry communicator or computer? No, this is some hard facts once again. Data is for computer communications emission. Okay, so you don't have image type. RTTY. Do you still remember what is RTTY? This is automated Morse code. So actually you have just 3 options in your mind: CW, data, and RTTY. So you already know that RTTY is about Morse code. So you can cross out this option. CW and RTTY, both of them are Morse. Manual mode and auto mode. Yeah, CW means continuous wave. So the last option will be data. So if you find out a FCC class, emission class that you don't know, just put data in it. Or sometimes they may have pulse, or a mix of them, which will be W. Mm-hmm. Image should be recognized as slow scan TV. Yeah, so they have slow scan TV instead of image. That's why they don't have image here. Yeah. Yes, this is something about the license again. But I'm not sure where should it lies. Let me have a quick check. It should be here. Yes, here you go. So the class of emission, okay, in NXP1, So you see that we have CW, continuous wave, telephone, television, radio, teleprinter, RTTY, data, fax, and slow scan TV. Okay, so CW and RTTY, basically they are the same thing. Okay, automated telegraph. But data, you see that data is, yeah. So if they are sending things in packet, you can group it in data. This is how it works. Okay. Let me check. Hey, how come it's so slow? Come back. Okay, I'm speaking which question? Oh, antenna tuner. Yes, impedance matching. No. This option is here is. Oh, wait. I guess Tim get it correct, right? No, you get it correct, right? What? I forgot your name. Yeah. But yeah. But the people come in class got it wrong. Actually, I've explained it in my class. It helps to impedance matching. Match impedance. Okay. They just changed the word. Okay. So what is antenna tuner? Let me grab my stuff first. Just a minute. Hey, how come? Just a minute. Oh, I'm set up my iPad. I'm setting up my iPad. Okay, great. So what is antenna tuner? So basically you have stuff like this, okay? You have your radio. No matter your or transceiver. So what will you connect to it? The radio. You will connect it to or maybe amplifier, that kind of stuff. You said yes. SWR meter. So still remember what is SWR meter? Standing wave ratio meter. To measure your signal. Yeah. If your signal emitting have an impedance match, okay, is this the best signal? That kind of stuff, okay. And you have an antenna at the back. For antenna, you will connect to an antenna tuning unit. So what is this antenna tuning unit for? Sometimes, still remember that our antenna is matching 1/2 lambda or 1/2 4 lambda, right? It have a very strict length relationship between the length and the frequency. Okay. So if your length changes a bit, your radio may not be receiving or emitting the desired signal, and this is we call impedance mismatch. And at this time, you also want your antenna to be able to emit or receive that kind of signal. You will need your ANT here, antenna tuning unit, to help matching your impedance. Okay, to prevent the SWR standing wave ratio growing too big, which is greater than 2 to 1 is too big. Okay. Okay. So once again, 1 to 2 SWR means 100 watts forward. You have 4 watts backward. Okay. Oh, just a minute. Yeah, this is how you do it. Okay. So that's why, for the simplest form of radio, you will have this radio SWR to measured if the power is good or not. If it is bad, then SWR grows very big. If it is good, then it will be very close to 1 to 1. An antenna, it will connect to an antenna tuning unit. Okay. Let's continue. Wait. Oh. Which one got it correct? Who got it correct? This is actually a very tricky question. I wonder who get it correct. Really. Let me just check. You? Who? Cynthia? Cecilia. Yeah. Yes. No wonder. So actually, you have to. I have talked about this in my class. Yeah, really in class. So over deviating, actually it's a word that's compared to, for AM, it is over modulation. It is about modulation. Talk about modulation. So if your AM receiver is over modulating, how do we do the modulation? Let me do it. Let me do it here. Okay. How to do the modulation? So modulation, we have 3 things in hand, right? One is your audio or input, the signal that you want to put into your carrier wave. This is carrier wave. So that it converts into electronic signals and can be emitted through our radio system. Okay. So once you combine both of them, for AM, okay, for AM, you will have something like this. Okay. This is what we call modulation. Okay. So if it is over modulating, what can you change? Can you change your carrier wave? It's hard to change your carrier wave because it is from the oscillator and the amplifier. So what you can do is you go to your audio and make your input much less, okay? Like this. Before it's like this, okay? So once you combine them, the resulting wave will not be overmodulated. Similarly, in your FM system, it is about deviation. It will not deviate far from the carrier wave, okay? This is actually tricky, and I've just talked about it in class. Yeah. But hey, I found this question in the question bank. That's why I put it here. Okay. So I've talked about all the hardest question. So do you have any questions that you want to ask me or want me to explain about it? I guess there must be some questions that you want me to explain, right? No questions?
Everyone.
Everyone? Everyone? Yeah, sure. I'll talk about it, this one. 1 month, yeah. So you have just 3 options in your mind. 3 days, 1 month, and 4 weeks, okay? So no 3 months, no this option, no 21 days. Actually, for questions about law and regulations, I just make them up. Oh, I have actually one reference, which is 創科小天地. I have talked about it in my very, very early time of my class, in lesson 2 or 3, okay? So yes, this is a very good reference, but in Chinese. So if you can recite all of the questions, you get a pass. Guarantee pass. Guarantee pass, yes. Because they will have questions exactly the same form, but they may just change some numbers.
Is the thing already in WhatsApp?
I have sent it very, very early time.
Very early.
Yeah, very, very early time. Maybe I just add it in the slide so that you can, know. Very, very early time in my class. Yeah. It's in the WhatsApp group. Yeah, in the WhatsApp group. And yes, plus they have nothing much to ask you about for the law and regulations. So if you can memorize nearly all of them, you already it will be very close to the pass. Okay, very close to the pass. Let me question. And for this question, I have spent. I've put more questions on laws and regulations. Why? It's because it is very hard to find questions for law and regulations, and most of the question banks are not included. That's why I have to make it up for this class, okay? And for the more technical stuffs about modulation, about the ionosphere, how propagation method, that kind of stuff, yes, the question bank have already provided you materials. That's why I didn't include much in my quiz, okay? Yeah, so bear in mind that. So in your real exam, you have 100 questions, right? You have around 30 questions about law and regulations. Yeah. So if you are not that good in math, recite Annex A, B1 and B4. Yeah. This one I have mentioned it, right? Oh no. This one I've mentioned it. So no 21 days, no 3 months. You have just three options. 1 month, 4 weeks, and 3 days. Okay. This is a very tricky question. I wonder who get it correct. Yeah, you get it correct. Why I say this is a very tricky question? So for the carrier wave, it appears here. Okay. 144 and 146. Why I pick this question? Pick this one. 144 and 146. It is we call it a V band, VHF band. Still remember what is VHF and UHF? V band. Yeah. This is a very common band that we use. And hey, you see that? The carrier wave, it is 14. DEP, AM modulation. After modulation, it is 20, right? And you see that it got a star, 14/7. So if you, in your exam, you only, if you can't memorize the exact frequency, you have just 4 options to choose. 7, 14, 20, and 26. Magic numbers, okay? Magic numbers. Yeah, really, really. 7 dB what? No 26. 26 is for, yes, here. PEP. All PEP, okay? No PEP goes beyond 26. No carrier wave goes beyond 20, okay? Maximum for carrier wave, carrier is 20. Okay. Yes. 14. 14 is for mobile. And 7, what is 7? Do you still remember what is 7? 144 to 146. Yes, there is an option 7, right? It's for portable, handheld radio, portable, which is /P. And for mobile station, what is that? So what is the difference between mobile and portable? This is we call it mobile for car, vehicles, for this mobile. And for portable, handheld radio. Yeah. And actually they got extra options called marine mobile, but it is not mentioned in the carrier wave or PEP. Okay? That's why I say this is a tricky question. If, hey, what if I just change it into portable? Then, yeah, this is 7. The answer will be 7. Explained already. No, Greece is actually tricky, right? But Singapore and South Korea, no, it's straightforward, which is wrong. A sure wrong, okay, Singapore. Because I have mentioned it many times, really. No Singapore, but Malaysia. Yeah. And Brazil. No, they're half facts, okay. You can't get this wrong. You should not get it wrong, okay? You should not get this wrong. Charlie Hotel, not Nancy. I just changed one word, okay? That's why it's a bit tricky. November. But in your exam, it's not that hidden, okay? It's more obvious. It's more obvious. Like they will give you 5 characters, right? They will give you around 3 to 4 wrong characters per options. Yeah, that's why they won't do it that tricky stuffs. But if you get this correct, yeah, that's okay. You will get it correct in your exam. Tricky question once again. ITU region, we split the world, for ITU they split the world into 3 main regions. Asia, region 3. How to memorize it? Europe and UK, region 1. This is what ITU origin, right? And what's coming up? America. That's why America is region 2. What's remaining? Asia. So that's why Asia and Russia is region 3. So once you know, oh, Russia is not. Russia is ITU region 1. Actually, ITU region 1. No Russia. Hey, let me just still remember this chart. Region 1, Europe, Africa, and Russia, okay? Region 2, so you just memorize, hey, Europe is the big brother, right? And then what's come the second is US. And what's remaining is Asia and Australia, which is region 3. Okay, so this question asks you a bit more on geography. So you know that's region 3, Asia, then the only options will be Japan. Okay. Cannot. FM band. Okay. So if you know 102.0 is the FM band, then you get this correct immediately. Yeah. No, we just got a valid amateur station license. Okay, we just got this license. No, no that kind of temporary station license or qualified amateur operator. No, we just check the ASL. Okay. Oh, is this? Oh, yeah. I've given you back already. Yeah, we have to PK. Still remember this. The first two characters will be about their country. Okay, the country code. So this is not that tricky. They can have more tricky options like VR2 SAA. So this is valid for people that just passed their RAE. No, cause let me check. Let me just do it once again. Let me grab my iPad. VR2, hey, for people who have just passed RAE, no more. What's their options? The options will be UAA to set. And how they mention it, how they address this in the document in your NXA, which is U to set one character with two characters following. Okay. Yeah, they really do that kind of stuff. Very weird. They are not saying that. The exact description will be followed by a letter U to Z, then followed by any combination of two letters. Okay, so they can trick you. They can change it into 3 and ask you if it is correct or not. So you know that the call sign is VR2 with 3 letters behind, right? But using this description followed by a letter U to Z already is one correct. It consumes one character already, and followed by combinations of 2 letters. That's why they can trick you. The official description looks like this, okay? Which is a bit tricky. VR2 U to Z and ABC, which is you pass the 5 words per minute Morse test. Okay? So if you have passed the 12 words per minute Morse test, which is AA to WZ, a combination of 2 letters. But it can be tricky. They got one exception, which is if you are a call sign for club, which is like VR2 HK, then we can choose any combination that we want. Okay? Yeah. For example, I can. So you see that the range C to D, C at D to T is not being used, right? So DAA to TZZ can be used by the club as their call sign. Okay? Which is the exception case. If you really, it's hard to memorize, forget it. Most important, U to Z with 2 characters. ABC, 2 characters. Or AA to WZ. The official description. Oh, let's continue. Good. At least two of you get the correct answers. Okay, so when can television be emitted? Which frequency can the television be emitted? Which the answers lies here. For television and pulse, only frequency above 5.725. That's why it is not permitted. What is telephone? Telephone means audio. So audio, you can use all the charts here, okay? All the charts here is for telephone, okay? What about slow scan TV? Slow scan TV is not television. That's why you can use all the bands, all the amateur radio band, or we say ham band. Okay. So only what's exception? Television and pulse. Remember these two, they are the exceptions. Oh great, actually you have to get these two, both of them correct. Okay. But I should deduct your mark. Oh, 2 to 4. Okay, never mind. Okay. Yes, the club must have a legal registered entity in Hong Kong, and supervisor must have a valid license. Okay. No. Primary language. No, it is not mentioned in your ASL. More than 25 members. No, they didn't mention about anything about the club size. Okay. Yeah, only one. Yeah, you can do it only one. So by elimination, you will know that hey, the remainings are correct. Yeah. Do I need to explain it? No, right. Yeah, long for MC, longest, correct. If 3 of them are short and 1 of them is very long, yeah, the long one is the answer. But how about 3 of them are very long and 1 of them is very short? Then the shortest must be the answer. Exam technique. Yeah, if you study in Hong Kong, then the teachers will tell you about the exam techniques. Okay. Explained? Okay. May Day. Do you know what is May Day? The emergency signal. May Day 3 times for aircrafts. Okay. No. Emergency. No, we don't do emergency testing. Okay. False and deceptive signal. Unidentified communications. No, you must mention your call sign. Still remember how we do the communications? CQ, and then you have to tell others what is your call sign. So you, by telling others your call sign, you are identifying yourself. Okay, that's why you should never do unidentified communications. Okay, no that kind of stuff. Even if you are trying to do the SSTV, slow scan TV testing, you must have your call sign printed on the image clearly. Okay. No, if you are doing tests, you can just put a dummy load here. By doing a dummy load, you are not doing communications. Okay. But if you start your connected to your antenna and try to do the communications, you must name yourself. Okay. And there is one more thing to add. So especially in mainland China, if you are doing unidentified communications, they can disqualify you. They can they will still drop you. How should I address it? Yeah, DQ you. Yeah. That's why no. Yeah, there's actually a rule in China. So memorize this. No, you must identify yourself. Yes. This is very obvious, right? But actually there is one more advantage. One more reason why you have to use the phonetic alphabet is because the accents. Yeah. Sometimes there are people in other countries that they can hardly pronounce the sound. Okay, but they give you a word, they can give you more rooms of thought, right? You can by listening to the remaining alphabets, yeah, so you can know which characters they are naming. Yes, I've mentioned it. Check the frequencies, turn on the radio and see if there are anyone using. If not, they can try to go with CQ. So the keyword here, testing or loading up procedure. Testing, dummy load. Okay, If you want to do your testing without emitting your signal, use a dummy load. This is how a dummy load works. Absorb all the signal, and you will not have any signals emitting to the environment. Okay? No. So that's why it is a substitute of the antenna. No. It's not about non-resonance antenna or about antenna. Okay. It is about the dummy load for testing purpose. Who get it wrong? I'm really worried. Who get it wrong? Who get RST wrong? No, I'm not going to find who is wrong. Okay. But no, it's readability, signal strength, and tone. RST tone. Still remember when are we going to use tone? Morse code. When we are using a key. That's why it is about RST. The T means how the tone is your key. Okay? How the tone is your key. That's why it's not tempo, but your key. Okay? Actually, it is obvious. Hey, signal speed and tempo, are they look alike? That's why, hey, you should be addressing to 3 different things instead of 2. Okay? Still remember that when we are going to use RST, when we are doing a key using Morse code, right? So in our audio, in telephone, we will just use R and S, no T. So you hear someone say that your signal is 5 by 9. 5 by 9. What does it mean by 5 by 9? It's your RS only. Your readability is 5, and your signal strength is 9. That's why sometimes you hear someone saying, hey, your signal strength is 9 plus 20 dB, which goes beyond 9. Actually, we have an S meter here. The S meter is here, okay? The signal strength. So you see a 9 needle, which goes beyond 8. You got plus 20, plus 40, and plus 80, plus 60. That's what it is. RST, how does it work? Okay? So remember this. It is very, very, very important. Distress call, which is the emergency call when you are in trouble. SOS, CW. It's tricky. QRZ is who is calling me. Okay? QRZ is, so I'm actually asking about the abbreviation. I didn't ask questions on the Q code, but hey, they will have one question about Q code. Propagation, VHF, line of sight. Most of the time you are doing line of sight, which is straight line, okay, or reflected line, reflected wave. Okay? VHF, UHF, the higher the frequency, the more likely it is in straight line, which is line of sight propagation. Okay, skywave, usually HF. Okay. Still remember why? Why we use HF for skywave propagation? What is the characteristic of skywave? It's just which part of the atmosphere? For the ionosphere. So only HF can be reflected by the ionosphere. That's why no. HF skywave. Hey, but if you are trying to communicate with a satellite, it is VHF and UHF, because it will not be reflected by the ionosphere. It will go straight into the space. That's why for satellite communications, they use VHF and UHF. Okay. Or we say dual band. Tunnel propagation, no that kind of stuff. Oral propagation, no that kind of stuff. Okay. Hard fact. Ionosphere region at night separate into 2 regions during the day. So in the daytime, we got layer D, layer E, F1, F2, right? But at nighttime, we just got E and F. We don't have D. D is disappeared, yeah, or diminished. No D, only F. So remember that F1, F2. That's why they combine at night. Yeah. Here's how can you memorize it. But if they really ask you about questions like this, they may have even more tricky questions, which is about spectral E. Spectral E. 偶發E層. Sporadic E. Let me check it. Sporadic E layer. This one. Sporadic E layer. Yeah. They can ask you about this one. But if they really ask you these questions, you just lose 1 mark. If you can memorize it, don't memorize. If you can memorize it, just forget it. Okay. Which is a special case in E layer. That's why I've talked about it, but I didn't mention a lot of details in it. This question is tricky because we didn't mention anything about EME. But moon bounce is actually very not that uncommon. Okay, quite popular for ham. Okay, how they do it is they transmit a signal and use the moon as a mirror and reflect it back. This is we call EME. And you know that for moon, they have a very, very long distance. And that's why you need a very pointy wave or a directional antenna. So this question is not tricky. So how do we understand the questions? Moon, far distance. That's why you need an directional antenna. So you see that isotropic, single dipole, round plane antenna. These 3 antennas are non-directional. The only directional antenna is the the Yagi antenna. So you don't need the word high gain array. No. It's just because of moon, long distance, directional. Yeah, this is the keyword. And yeah, we can talk more about high gain and array. Antenna array means we combine 4 antennas together, forming an array, and then we point to the moon and do the signal transmission. And this is one characteristic of EME, is you will hear the delay, because it takes quite a long time to travel from the Earth to the moon, and you need to wait to signal reflect back. That's why when you are doing the communications, you can always hear yourself with a bit delay. Skip song. There's one guy forgets to submit his or her answer. Who forget? I just received 3 response. Who? You? Do you want to? No. You gotta get answers. Okay. Skip song. No. Different from an area covered by skywave propagation. It is the area that the skywave cannot reach. The area that skywave cannot reach. Once again, let me grab my iPad. So sometimes you also see ground wave, and yes, in some textbooks they also mention about ground wave, because they use ground wave as a complementary. But you don't need to memorize this one. Okay. This is the Earth, and let's say this is an antenna. This is the ionosphere, okay? So I use red as the signal. So when the signal goes here, how the wave travels back to the Earth? Refract, okay? In textbook it is refract. If they really ask you about either if it is reflected or refract, then refract will be the answer. But in daily communications, we use the word reflect. Okay. But never mind. You know that it will eventually travels back to the Earth, right? So we got a distance here. We got a distance here that they cannot receive the skywave signal, right? This is the skip distance. The length is called distance, and the area will be skip area. Okay. So you know that, hey, this is just one. Actually, I guess some of you will answer this one, but no. Yeah. So remember that it is before the skywave refracted back to the Earth, the area that it cannot receive the signal. But if you are doing a vertical signal emission, you have a you won't have a skip zone. Okay. And if they ask you about the skip zone, there are some more keywords that you can memorize at the same time, which will be the 臨界角度. Let me check the English. Just a minute. Critical angle and maximum emission angle. Some words like this, as I remember. Yeah. Maximum usable angle. I guess there's some keywords like this. You can refer it to my slide because I forgot it. Yeah. But critical angle will be asked if they ask you about skip zone, about skywave. There's some keywords related. Okay. Interlock switch in high. Oh, does anyone don't know what is the interlock? Oh, if you don't know the interlock, don't worry about it. The keyword is why the power is turned off when this cabinet is open. Easy, because safety. High voltage turned on. So all the things in the cabinet will have a very high voltage and very dangerous when you touch it. That's why it is for safety precaution. Okay? Prevent from getting shock by high voltage. Okay? SWR. Yeah, I forgot. Increase to 5 to 1. Yes, they will ask you about questions like this. So you see that when for the lowest frequency it is already 2.5.1, which is already bad, and increasing the frequency even worse. Okay. So for a good antenna, maybe 1. I just make up some numbers, okay? This is when you at your desired frequency, it will be very close to 1. Okay, very close to 1. So now I'm going to tell you about that. Hey, at the lowest frequency, it's already 2.5 to 1, and at a higher frequency, it is 5 to 1. Then when you extrapolate the curve, it will look like this, right? That means the desired frequency of this antenna lies here. That's why it is always too. The antenna is too long. Okay, antenna is too long. No. So this is not just right. No. If you see that the frequency already 2.5, increasing the length, increasing frequency 5 to 1, no, it is not. So if you beat this kind of questions, the only answer, if you don't see 1 to 1, okay, or 1.2 to 1, the only answer you have is, oh. Okay, you have actually 3 cases. Let me go to it. Okay. You have antennas. Let me use different colors. So for this one, the green curve, okay? So if they tell you about it, the lowest frequency is 2 to 1, and the highest frequency is also 2 to 1, then you know that, hey, it is receiving at the correct frequency. Just right, okay? Just right. But if they tell you about it, hey, when I'm receiving this one, like this one is 1.5 to 1, and this is 5 to 1, this is too short, okay? No, this is too long, and the green one is too short. The explanation is in lesson 10, I guess, lesson 10. So you can go back and check the slides. You won't get this one wrong, right? SI units, but yeah, SI units will be asked. So kilo, mega, that kind of stuff. Okay. Easy, right? This one. Easy. Antenna tuner, impedance matching. So I've explained to you already. How they do the impedance matching is because the antenna tuner itself consists of two main parts: a variable inductor and a variable capacitor. That's why they can tune the capacitance and inductance for impedance matching. Okay. This one is tricky. Bandpass filter. Yeah. Do you know what is the IF section? The IF is called intermediate frequency. So the intermediate frequency is the frequency for AM it is 330 kilohertz, and for FM it is 10.7 megahertz. Okay. So you are putting the signal that you received to intermediate frequency for processing. Okay. So for this region, you just want to have 10.7 in or out. Okay. You don't want other signals going to your IF region. That's why you use a band pass filter. Okay. Blocking anything above or below. Yeah. No, that kind of things called input filter. Okay. For filters, differentiate by classes: high pass, low pass, band pass, band stop. They got an extra name for band stop filter, which is called notch filter. Okay? Notch filter. And if they ask you about amplifier, other types of filters, it will be related to the radio or transceiver, the combination of it. Okay, the components of it. Okay, let me check. Yes, information with radio signal, which is the carrier wave plus your audio. This is modulation, putting your audio or the signal into the carrier wave transmission. So what's demodulation? Demodulation is you receive the signal, electronic EM wave. You receive the EM wave and you want to put it back into audio. Okay, you want to turn it back into audio. This is we call demodulation. Okay, transmitting, modulation, receiving, demodulation. Okay. Let's see. Upper sideband. I really guess all of you get it correct. What is USB? Upper sideband. Upper sideband is a variation of single sideband. Okay, single sideband. You got. Do you still remember what is AM? Amplitude modulation. Amplitude modulation. AM. We call this point lambda, which is the point you want to transmit a signal. And you have, okay, this is the AM. This is we call the CW. And the CW itself, it does not contain information, which is wasted energy. Okay. So if you are interested, this only consists of 1/6 of the power. Okay, this consists of 2/3 of the power. So that's why you see a lot of energy is wasted. Let me put it this way, okay? You can do your calculation your own. This is V, okay, right? Voltage V, right? And this is, the amplitude will be 1/2V. Okay? That's why you can do your calculation and check why it is 1/6 for each of the sideband, okay? But I'm not going to talk too much because I don't think this will be asked in your exam. Just as an additional information for you. Okay? DSB, which is double sideband. At this time, you won't have the carrier wave. You will have just this one and this one. Okay? This we call double sideband. And SSB, you will have just one of them remain. So this part is we say it louder. Okay, this part is higher frequency. So we call it upper sideband. So obviously, what is this called? This we call LSB, lower sideband. Okay. This two region is we call sideband. Okay. And the region that will contain your information. Okay. Only the sideband will contain the information. The carrier wave will not contain any information. Okay. This is the carrier wave. Okay, clear? Good. So obviously for FM, no, just FM. You don't have that kind of DSB or SSB in your exam. Okay. That's why now you know that it's never above 10 megahertz. Okay. This is tricky, right? Below is LSB, lower sideband. I explained it. This is a tricky question. Multiband antenna. Yes. Oh, do you still remember what is a balloon? Balloon, which is balanced to unbalanced converter. That kind of stuff. To convert the signal from a balanced system into imbalance. Like for dipole, they got two different metal pieces, right? Which is a balanced signal. But the coaxial cable is only transmitted. It will only transmit the unbalanced signal. Okay, using the metal piece at the middle. Okay, that's why you need to use a balanced to unbalanced converter balloon to help you to convert the signal from balanced system to unbalanced. Okay. Multiband, yes, it radiates harmonics. That's why for multiband antenna, they will have a band stop there, yeah, to prevent harmonics and unwanted frequencies. Yes, harmonics. If you play instrument, then you will know. It is always the integer multiple of the frequency. Always the integer multiple. Okay. So if it is slightly more or less than the desired frequency, it is surplus, or we just say noise. Okay. We don't use harmonics to address this kind of noise. Okay. These are tricky questions. Okay. Why? Because frequency discriminator is only applied on FM system. For AM system, it is called demodulation. AM demodulation. So if you want to recover your audio back for FM system, you use discriminator. which appears only in FM receiver. Okay, so variable frequency oscillator, no, it is for combining the mixer. Okay, so for receiver, you got this one. This is the antenna, this is the oscillator. So that pass will go to the intermediate frequency for other processing, like amplifying, that kind of stuff. Okay, so the variable oscillators goes here. When you have an antenna receiving the signal, oh, do you still remember what is this one? What is this? This is the mixer. What is the number of amounts that a mixer will give you? If you put 2 inputs to it, how many inputs do you have for the mixer? How many outputs will you receive? You will receive 4 outputs. Which 4? F1, F2, F1 plus 2, F1 minus 2. Okay, or 2 minus 1, depend on which one is larger. Okay. So for antenna, it will, like if it's an AM system, you will receive like 800 kilohertz, and the oscillator will give you a frequency to guarantee you are receiving 450 kilohertz here. Okay, for AM. So this is how the variable oscillator works, to guarantee your IF is 430 kilohertz or 10.7 megahertz for FM. Okay. Because for antenna, you are not going to receive single frequency, right? You are going to tune your frequency. The variable oscillator will change at the same time with the antenna to guarantee single frequency is used for IF. Okay. Superhydrogenate receiver, the best receiver for AM. So that's why it is not an FM receiver. Okay. Yeah. No double conversion receiver, no that kind of stuff. Okay. So that's good. We got 15 minutes left, so let's talk about something very different. Okay, so for your exam, you have 100 questions, and you know that 30 questions. Oh, but when I do my exams, I remembered it should be lies between 30 to 40. Yeah. So when you are already very familiar with the ASL, you know that, hey, the remaining questions I can just guess them. Okay. But no, I know that most of you are very good at math here. Okay. So for like Ohm's law to deduce that kind of electronic circuits, it will not be that difficult for you. Okay, it's not that difficult for you. You can just, if you want more questions, just ask me. I will bring my question, the question bank that PK Sir gives me later time, but it's all in Chinese. Yes, I guess the questions will be similar. The difficulty will be similar to this kind of questions, or just a bit harder, just a bit. Yeah. Okay. So do you have any questions to ask me before I go to the revision session? No questions? Do you want to have a 5 minutes break first, so I can spend 10 minutes, or I can just go ahead? Do you need some time to digest the materials that we just go through?
Sure.
Yeah, you can stretch. So we have got 13 lessons. I checked my schedule, the team schedules. That's why I found that, hey, we've got 13 lessons.
Tomorrow, next week, the last one.
Yeah, next week will be the last one. Yeah. So if you have any questions, after lesson 13, you can just ask in the group. Okay. You must have some questions when you do your revision. Yeah. It's a must.
I forgot where I got this.
Oh, really? Oh, let me.
Is it
Thank you.
useful?
It should be useful. Welcome over. Oh, actually, I just got one part. Yeah, you can take a look first. I guess you can just pass it to them. Yes, this is the exact difficulties you will met in excuse me, in your exam. Okay. I will share more materials to you tonight. Yeah. Don't worry. Yeah. If you will do your revision later time, and you already get a pass here, then you don't have to worry about it. Yeah. Really, you don't have to worry. But you see that I put nearly half the questions for rules and regulations, or the ASL, the ordinance. So in your real exam, you will know that you got more petitions asking you about the calculations, the concepts of radio, concept of propagation, concepts of electronics. Okay. Oh, because they don't attend my class today, so I can talk about it. I'll talk about this one. Okay. Yes, your exam will be exactly like this one. Exactly. Yes. I really made questions exactly like this in my exam. Yes. So you see that, hey, I've just do a lot of translation, especially in the rules and regulations part. So that's why she didn't remember the answers, but she remembered most of the questions. Yes. That's why I changed some answers and I have give you more tricky answers. Like they will give you this one, which kind of filter is this? So this filter, to see that what is this? This is actually the curve telling you the negative minus 3 dB point. Okay, minus 3 dB point. So you see that the signal goes weaker at low frequency. In other words, it just allows high frequency to pass through, which is high pass filter. Okay, if you know the Chinese, then you know it. No, they didn't ask you questions. Yes. How long should you keep repeating your call sign? 15 minutes. Hard fact. How long should you keep your record? At least 6 months, which is in your ASL. Okay, 6 months. But if they, it is must, right? But OFCA will suggest you to keep it as long as possible. Yeah, but at least you need to keep it 6 months. Change frequency, Q code. I don't remember it. Never mind. Just guess it. I didn't tell you about 自動轉接. I didn't tell you about anything about automation, right? Which is 中繼. Let me check. What is the English of 中繼?
Repeater.
Yeah, repeater. Which is automated to connect the signals for you. Repeater, yeah. There are nothing from Earth radio, Beacon radio. Beacon radio. They really have something like this, but no, you know that it is repeated. Blade resistor. If you are not familiar with the electronics, you won't study it, right? But if you study it, it's for protection, just like a fuse. It's for protection, limiting the current. Okay. So can you draw LED? They will give you pictures like this. Okay. So when you receive your question set, don't be afraid of it. It will consist of a lot of pages. When I take my exam, it is 37 pages, 37 for just 100 MC. But for English, it is 36. I don't know why. 1 page less. Like, they will also ask you about RMS. So do you still remember how to do the RMS? 1 over root 2, 0.707. Peak value, RMS to peak value multiplied by root 2. This is quite important. I forgot to do the. Just a minute. Hey. How come? Let me have a quick check. Okay. RMS. Before my iPad come back, I'll just do it with my son. Okay. Yeah, good. My iPad comes back. Oh, hey, where are you? So for AC, perfect AC, you have sine wave like this. Okay? You have 4 values in your mind. This one, this is peak, to peak. Okay, peak to peak. What is the value of this one? Amplitude, voltage, current, all of them okay, but most of the time they will ask you about voltage. How about this one? This one is we call peak. Okay, let me choose another color. This is 1 over root 2 V RMS. And 2 over pi, this is the average. Okay, so RMS, if you can remember the exact formula, you can do this one. RMS equals to 0.707 peak to peak. Peak times peak, okay? And average will be, let me do my calculation very quickly. 2 divided by pi. What is the value? 0.637 times peak. Okay? So if they ask you about RMS, that kind of stuff, you can just do the conversion. Okay? But I prefer to remember the exact formula. It's easier for science students. Yeah, so inductance, I guess I didn't ask you about anything about calculating inductance, frequencies, that kind of stuff. But LC resonance will be asked in your exam. LC resonance will be asked in your exam. Okay. This one, it is the FET, field emission FET. Transistor, yeah, and they will ask you about which is P-type or N-type. They may ask you questions like this. I haven't go through it in very detail, so let's see if we have time next lesson. Yeah. And NP junction. What is the things that consist of NP junctions? Diode or If they have two NP junctions, then it will be transistor. Okay. Yeah, P-type conductor. What is the carrier? Positive hole. Positive hole. 空穴，電子空穴。Which type of amplifier have the the minimum loss, okay, minimal loss. A type, B type, A C type, and AB type. A type is lossless, so that's why the answer is A type. Okay, A type is lossless. Yes, they will ask you. Actually, she mentioned that the electronic circuit is not correct, but actually this is correct. This is correct. I made exactly the same diagram in my exam. Yeah, exactly the same. That's why they asked you how to do the frequency. Yeah. But never mind, you don't have to worry about it. For this type of questions, you know that how can you output the 2 MHz? What is the frequency for outputting 2 MHz? The LC resonance. Still remember what is the LC resonance? When reactance of capacitor equals to reactance of inductor. At that frequency, it is called resonance. Conductor, Xc equals to 2 pi Fc, right? For inductor, the reactance will be L2 pi Fl. So that's why at resonance, Xc equals to Xl. That's why 2 pi Fc equals to, you see that I don't remember the formula because I forget it. I always deduce it once again myself. Okay? F equals to 2 pi root Lc. That's why when you see the how come you are not telling me? I'm not showing my screen. Okay, this is how you do the calculation. Okay, at resonance, LC resonance. Okay, so there is 2 forms of LC resonance. For parallel, the impedance goes like this. For LC in serial, the impedance goes like this. Okay. Impedance is set. Okay. Yeah. But never mind. You don't have to worry about it. You just have to calculate what is the L. How can it output 2 MHz? That's enough. Okay. Yes, at most. So last time when I talked about in my class, lesson 11, I have shown you a diagram about the Boolean. So you know that the hardest part will be like this. The hardest part of the Boolean circuit will be like this. So if you're already familiar with the AND gate, OR gate, exclusive OR, NAND, AND, OR, that kind of stuff. Oh, it is an AND gate, OR gate, and not. Okay, then you deduce yourself. The easiest way to handle this question is drawing a true false table. Okay. Yes. So if you have they will ask you PLL. I didn't mention anything about PLL, but yeah, if they ask you PLL, then you just divide the 2 numbers. This is the answer. Okay. I have some questions that I didn't ask, right? About the Yagi antenna, what is the component, the name of components, that kind of stuff, blah. Hey, but if you have time, spend a few days to understand all the concepts behind, guarantee pass. Yeah. If you don't know the math or you are not sure about the translation, the English term, you can ask me. I have mentioned like all the terms already in my slides. The terms in my slides are accurate, okay? Because I copied them from the textbook. So if you have questions, ask me. We'll do the revision once again next lesson. So you can also bring the calculator with yourself, so we can know how to do the calculations.